welcome back. I hope you had a chance to rush off and get yourself something to drink and some more paper and pen and what have you. Remember, you can contact us on 086 1058 262 or on Facebook, www.facebook.com/learnx, letter X, TRA. Right, so please get hold of us. And I'm delighted to have a caller on the line. I don't know if he's with us yet. Oh, good. Yasmin, can you hear me?
Yeah. Hi, ma'am. How are you?
I'm very well. Good to have you with us.
All right. Thank you so much, ma'am. Also me.
No, it's a pleasure. I just hope this is something that seems to have come up on Facebook, so obviously it's a good question to be asking at this stage. It says, given that f of x is 4x squared plus is not cubed, I think that might be a cubed, am I right?
All right.
Because if it's a cubic, it must be a cube, okay?
All right, ma'am.
Plus 27x squared minus 30x minus 1.
Yes.
And they give you the curve, and they start asking you questions. So now what I'm going to do is ask you which sections you would like me particularly to go through.
All right.
And then I will, if I don't need the work for anything else, then I will just introduce how we'd start the questions off.
Yes.
Right, so which ones did you particularly want me to do?
It's actually 5.1 and 5.4 that I'm having a struggle
So
with.
it's 1 and 4 that you particularly want. Okay, great. Right, now number 1 says determine the coordinates of A and B. Now, what is the technique that you do as soon as you look at that? Because what are they telling you about A and B in the drawing?
They're telling me that A and B are the turning points of the graph.
Correct. They're the stationary points or turning points of the graph. And from the previous segment, what do we know as a result of that?
Is that we have a minimum and a maximum value.
Correct. And obviously this one would be the maximum and this one would be the minimum, just looking at it graphically. But you agree with me, it's not the total maximum and the total minimum, because this graph would continue down here, so it would go lower than that.
Yes.
And this graph would continue up here, which means it would go higher than that point. So we call them local maximums and local minimums. So in other words, in a little localized area, there's the maximum, and in a localized area is the minimum. But in actual fact, as you say, it's a stationary point. Now with calculus, as soon as we see the word stationary or turning point, or we're looking at a graph that is showing me that that's what I'm working out, what are we going to do?
I think we're going to have to find our first derivative based on the f of s.
Correct. We're going to find our first derivative. So let's do that over here. So I'm going to say, well then, f dashed of x would be, right, what would it be?
It would be 12x squared.
Correct.
Plus 54x.
Correct.
Minus 30.
Delightful. And you can see these numbers are just fantastic.
Right.
And I think they're trying to scare you with the numbers more than anything else. Okay, now I'm just going to extend the page and go and put this down here so we've got more space to write. Okay, so after the first derivative, what is the next thing we would do? Because the point of finding the first derivative is we're actually finding the gradient.
Right, ma'am.
You agree?
Yes, ma'am.
And if we're looking for the stationary point or the turning point, what do we know about this gradient?
The gradient would be 0.
That's right.
Okay.
Because what happens when we're looking at this curve, so let's go here, the gradient is positive, it levels out here, and then it becomes negative. So in order to pass from a positive gradient through to a negative gradient, it had to pass through a gradient of 0. Likewise here, it's negative through to positive, and this must be, again, a gradient of 0. So you're quite right. That's what we're going to do. So we're going to say for stationary points or for turning points, I like to do this. You know, some people argue, well, you know what, you don't have to do that. But I always think if you're setting out your work really well, it helps the examiner to follow your thinking.
Okay.
Okay, so we're going to put that as 0. So 0 is equal to 12x squared plus 5x minus 30. Okay, so right, what are we going to do now?
I think we're going to have to factorize it.
Correct, and we can see it's not the prettiest factorization in town.
Yes, sir.
It's actually quite awful, in fact, because you can't even take out a common factor. So now it depends. You can use your calculator, of course, but let's try and be good and not use the calculator and just think it through. We want to get a relatively small number in the middle here. So I'm almost thinking 3 and 4 to get 12. And 30, let's try 6 and 5 and see what happens. I mean, I probably am wrong in where I've got it. In fact, I can already see I'm wrong, because over here I would get 24, and over here I'd get 15, and the difference between these two is not 5. So what I would do is I put 5 there and I put 6 there.
All right.
Okay, is this where you're finding it hard? Is this like kind of factorization?
You see, ma'am, my problem was that I was wondering if I could use a quadratic formula.
Yes, there's absolutely nothing wrong with that. They didn't say you couldn't. All it is time consuming.
Oh, okay.
But if you're going to get it wrong by trying to factorize it, it's better to use the formula. So I would agree with you. So if you look at this and think, this is pretty hideous, so let's just use the formula, there's absolutely no reason why not. The only thing you do is you penalize yourself through time, but actually not, because if you're going to struggle to factorize, it's going to take you longer.
Yes, ma'am.
So I think that's a wise move on your part. I think it's a very good way of doing it.
Oh, okay.
So yeah, I would get 18 and I get 20. And you know what, I'm looking at it and I'm thinking, you know what, you haven't got a bad idea here. So let's do the formula. So we know that x would equal minus b plus minus the square root of, and I'm being quite naughty because I'm not writing the formula down, because in actual fact, even if you did do that, you wouldn't really get any marks for it because it's on your formula sheet. But you know what, again, it comes down to if you're likely to make a mistake, rather write the formula down. And quite honestly, to be honest with you, I think that this on the formula sheet is a waste of time. By the time you've looked it up, you could have rather learned it. You've used it so many times in the grade 10, 11, and 12 year that I'm sure you know it off by heart. You don't even have to look it up.
Yes.
So there's your A, here's your B, here's your C, so it's minus B. So then it'll become B squared minus 4 times the A times the C. Now I can see this is going to be a lively one for your calculator to come into action to make the arithmetic easier.
Okay.
I don't know what we did before calculators. Actually, I do. We used to use horrible books. But anyhow, back to the calculator, which is much more friendly and nice. And what I'm going to do, because the calculator is quite low, let's see if it comes up. Oh, yes, it does block it a bit. So I'm going to raise it ever so slightly. Hopefully that doesn't mess up the cameras and everything. If it does, they can shout at me later on. Right, so if we look at this now, we're going to find this formula. So we're going to say minus 5. And obviously, we can't do them both at the same time. So let's go plus. And now we need a square root sign. And inside the square root sign, we're going to have 5 squared. But I'm going to be lazy. I'm just going to go 25. And then over here, we've got minus 4 times 12 times negative. And oops, I've just realized, you know, it's fine. It did it. That's fine. Negative 30. And we're going to press our equals button. Oh dear, I thought it wouldn't do it. When I looked, I thought, oh, this doesn't look good. Back to the drawing board. I think where it doesn't like is working with these double negatives. So fine, let's go back to the formula. It's minus 5. And I think I was doing the plus. Oh, careful. Sorry, let me just clear this calculator. Clear. That's it. Great. So I want minus 5. No, it's still doing it. So let's clear again and let's try this negative. Yeah, that's the problem. I was using that negative instead of that negative. Negative 5 plus the root of, where's the root gone? And it's going to be 5 squared, which is 25. And it didn't like that, so let's just go again. Okay, it says choose an ink layer. I don't want to choose an ink layer. I'm using my calculator. Okay, this calculator's decided to give me a few grey hairs today. I don't know, I've obviously done something to it. All right, I'll tell you what, let's try and work without the calculator. I think my arithmetic is probably up to it.
Okay.
So let's do that, and you can help me out too if you've got your calculator handy.
All right, ma'am.
Okay, it's almost like frozen. So you know what, we might even have to go to an ad break to just get this calculator working again. Let's just try one more time to move it, and if it doesn't move, no. Okay, so I'm going to have to go to ad break, and then I'll be back with you. I do apologize. We're just going to have to get the calculator unfrozen, because that's what it's done, and then be able to come back to your question. I would have tried to do it without, well, let's see if it'll let me, no, it won't let me write. Okay, fine. So we're just going to go to a break, and then I'll be back with you, and we can carry on with the questions you'd like to know more about. All right, we'll be with you shortly.